Hello everyone. Today we are solving another example on PDA. So the question is design a PDA to recognize a raised to m, b raised to n and c raised to m plus n, and m and n should be greater than or equals to 1. In the previous videos we have learned about the patterns like a raised to n, b raised to n and a raised to n and b raised to 2n. Okay, so in the previous video we have seen for two alphabets, input alphabets, and for one power, means here n, here also n, here n and here 2n. But today we will solving a new example on a raised to m, means there are two variables m and n for the powers and three input alphabets a, b, c. Okay, so first step is our theory. Step 2 is our logic. Okay, in theory I told you in the previous videos we have to write the definition of PDA. It's a mathematical model for the PDA. I showed you in the previous video. You have to write this. Okay, so what logic we can implement? As you see, for a raised to m and b raised to m, c raised to m plus n, means if there are m a's and n times b, then there will be m plus n times c. So what logic I can implement here? See, a raised to m means if here it is indicating that m and n both are greater than or equals to 1, means there is no relation of m and n here. M can be 2 also, n can be 3 also. M can be 1 also, n can be 3 also. Means any combination of m and n. Okay. Now see, if I taking as m equals to 2 and n equals to 1. So what here? A, B 1 times and C will be 2 plus 1 3. So C means for this both are different. Now see, there can be m times a, n times b, and c will be m plus n times. So I can implement the logic like that. For a we will push x to the stack, for b also we will push x to the stack, and for c I will pop that x. Now see how it is possible. For 2a I will push xx, so there will be 2x in the stack, and for the single b I will push 1x again, so there will be 3x's in the stack. Now there are 3 c's also, so for every c there will be one pop operation. Okay, means I have segregated this, means this and this becomes the equal, means for this times x and this times x popping is equal. So what? See, I am writing the logic here. For each a push 1x, for each b push 1x. Since a raised to m and b raised to n and m plus n is the c power, that's why I am pushing a, I am pushing x for a also and pushing x for b also. For each c pop 1x. Okay, now see, we have to write the states. So I am writing a q0 starting state, and I will write afterwards z0 I am assuming as z. My input alphabet is a, b, c, and my stack alphabet is, I will push x only, so x and z. Now anyone can think like, for a I can push x, for b I can push y, and for c I can pop x and y both. Yes, you can do that also, but it will become complicated at the last. While popping for x and y you have to write more transitions, means you will say yes for y, pop y, yes for x, you can pop x, no issue, but there will be more transitions. So I am taking x as a common for pushing a, while a, and for b also. Okay, so now see, our step 3 is our implementation. implementation. Okay, now see, A followed by B, then followed by C. So starting with Q0 A and stack top will be Z only. So what I will do, I will in the same state I will push one X. Okay, now see, Q0 A, there can be means X will be the top, so again in the same state I will push. Okay, now see, I am taking an example A, B, B, B. So M equals to 2, N equals to 3, so C will be 5 times M plus N. Okay, so see, for starting condition, this transition for this, for second A or many times A after the first A, this transition will be applicable. Okay, now see, if B comes, B will first come in a Q0 state. So I am writing Q0 B and stack top will be X only, because B will come if and only if A comes, means A will come, then after B comes. So stack top will be X. So what I will do, I am changing the state, so I can keep the track, or it will be very easy for me to solve. Now see, Q1 XX, Q1, now B X. What I am in the same state, I am pushing only. This indicates pushing only. Okay, now see, Q1 Q0 B comes, going to Q1 and pushing 1X. Q1 B and stack top is X, so it is pushing again. Now for this B, Q1 BX, it will again push. Now say Q1, now it is in Q1 only. Now for C, C can come in Q1 and C. Okay, so what I will do, if C comes and stack top is X, what I will do, I will say change the state and pop. As I told you in the previous videos, this indicates pop operation, so I am using this here. Now see, it has changed the state, Q2 C and X, means stack top can be X also. What I am saying, same state, stay in the same state and pop again. Okay, now see, in Q1 BX, we are in the Q1 and we are pushing XX. Okay, I am drawing one stack, so it will be helpful for you. Z, see, A comes X. Now for this A, second A is in the same state Q0, we again push an X in the same state Q0 only. Now B comes in the state Q0 BX. So what I will do, change the state. Now I am tracking a state Q1 and push one X. Now C is in Q1, now second B comes this BX, stack top is X. So what I will say, push X again. Now see, this third B, again B comes, but we are in the same we are in Q1 state, so Q1 B and stack top is X. So I will say push again X. 1 2 3 4 5. Okay, now we are in the Q1 state. Now C comes, C Q1 state and stack top is X. So what I will do, pop and change the state. Now it is Q2. Okay, same way Q2 CX. Now Q2 and second C and stack top is X. I will do pop again in the same state and stay in the same state Q2. Same for this, again pop, stay again in Q2. This again pop in the same state, and for this last C, again pop and stay in the same state. Now see, C's are over, means string is now empty. What I will do, last Q2 empty string, and if the stack top element is Z, what I will say, go to the final state without any pushing or popping. Okay, so this is my implementation. Based on it, I will draw the transition diagram. Now see, there are three states. I am writing this Q0, Q1, q2. Okay, yes, and qf will also come, and I write a final state as qf. This is a finite set of states, so starting state and final state will come in this set, but I will show here that final qf is a final state. Okay, now see, based on the implementation I will draw a transition diagram. We are in the q0 state. In the q0 state, if this comes, what I will do, az comes, push xz. Okay, if ax comes, push x again. If bx comes, go to q1. B comma x comes, push and go to b1 state. If b1 x comes in a q1, means in the q1 state, b1 b comma x, sorry, b1 a b comma x, so you will push again. Now see, q1 cx, if to change to q2 and pop, so what I will do, change to q2, cx comes this. Okay, now q2 cx, so in the same state only, cx to pop again in the same state q2, and if the null string comes, so don't push and pop anything and go to final state. Okay, we have to draw like this. See, this I have to draw, and I am used here epsilon as a popping light, so that's why I write here this. Okay, it is correct. Now step 5 is example. In example, I am taking like q0 a b b c c c. I am taking 1b c c c. Now see, 2a 1b. What is the value of m is equals to 2, n equals to 1. So m plus n is 3. So see, 2 1 and here 3. So it means it must be accepted. So let's check. q0 receives a same state, push x. q0 receives again in the same state, push x again. q0 receives b, changes to q1, push x. q1 receives c, go to q2, pop x. q2 receives c, in the q2, pop x. q2 receives c, null string, pop x. So only one z, means the stack top is now z. So q2 null string and z. In the transition we have seen qfz. qfz means we have gone to final state, it is accepting. Now let's take an example of rejection also. q0 a b b c. Okay, and here z. Now see, m is 1, n is 2, so m plus n becomes 3, but here it is only 1 c, so means it will be rejected. q0 receives a in the same state q0, b b c, and x is pushed. q0 receives b, goes to q1, b c, and x z. q1 receives b, q1 only, x z. q1 receives c, pop, go to q2, x z. Now see, we don't have any transition of q2, null string, and stack top is x, so this means this is rejected. In this way you have to solve examples of exception as well as rejection also, and you have to draw transition diagram, implementation, to write the logic and theory. Thank you.